Okay, hello everyone. So this time I'm gonna talk about like seven true or false questions here in our like intro to probability midterm. So let's get started. For number A, there exists a discrete random variable x such that the expectation of x equals to 2.5, whereas p, the probability of x is less than 2.5 equals to 0.9. So this is actually possible because we can think of like some of the overlay like outliers which are very big, much greater than 2.5, but they only like 10% of they're only 10% of the whole like data or the whole distribution. So these outliers will make the expectation smaller, as small as like 2.5, but actually they plays a role like only 10% of the whole distribution. So thinking this problem in an extreme way will help us to figure this out. For the second one, suppose you're offered a bet where there's a half chance that the balance in your bank account is increased by 1% and 50% chance that the balance is decreased by 1%. And so we can know that the expected value of this bet is $0. And yeah, we have something in the parentheses to make this explanations more clear. So this one I got it wrong because I think if you play a couple of like a multiple of times, your your money will change and and 1% of different like 1% of different amount of money is different, so the expectation cannot be zero. But this question is asking like if you only play one time, only play once of this game, what's the expectation money you will get. And this is obviously like zero because you can use 1% times 50% plus -1% times 50%, you can get to zero. So yeah, this is quite simple. And for C, if X is a Bernoulli distribution, Y is also a Bernoulli distribution, and they are random variables, but not necessarily independent, then EXY equals to PQ. This so this is not necessarily correct. Suppose like if X and Y are like identical, then EXY equals to EX squared. Because this is a Bernoulli like this is a Bernoulli distribution, we can know like EX squared equals to EX, which is P, not P squared. So for letter D, let A1, A2, A100 be events but are not necessarily independent, and let 1A I be the indicator random variable, which is 1 if event A occurs and 0 otherwise. Then E, the expectation of 1A1, 1A2 plus plus 1A100 equals to PA1 plus PA100. So this is actually correct, even if they're not necessarily independent, because like this is a mathematical thing, because like the linearity of expectation value is always like true, even if they're not necessarily independent. So the equation here is just simply you unfold the left hand side to E1A1 plus E1A2 plus plus E1A100. And so according to the definition of what is 1AI, like the indicator random variable, we can know that E E1A1 plus E1A2 plus plus E1A100 equals to PA1 plus PA2 plus plus PA100. So yeah, and for letter E, if X models a number of rolls of a die before rolling the first four, then X is a exponential distribution of 1 over 6, which means X follows an exponential distribution with lambda equals to 1 over 6. But actually, this is wrong because this is, according to the definition, this is actually a geometric distribution. And yeah, this is not an exponential distribution. For F, if A and B are independent events and B and C are independent events, then A and C are independent events. So this one is actually false because like we can find some A, B, and C such and we can find like PA intersects B equals to PA times PB and PB intersects C equals to PB times PC, but actually PA intersects C does not necessarily times PA and PC. You guys can find some examples in such as dice rolls or something, and yeah, you can verify this by yourself. So for letter G, given a sample space omega, there exist independent events A1, A2, an belongs to omega such that the sum of PAI is greater than 1. So for this one, I get it wrong, but actually it is true. Like for an extremely weird example, like if A1 equals to A2 equals to omega, so PA1, I mean PA1 happens under the condition of A2 happens, like they are independent, but they are the same event because PA1 times PA2 equals to omega square, but like PA1 under the condition of PA2 happens is 1. So like which means P omega intersects omega equals to P omega square. So like A1 and A2 both have the probability of omega, but they are independent. So here PA and PA plus PB is 2. So this is actually larger than 1. So thinking it in extremely will also help explain this problem.